In this video, I consider the problem of solving the quadratic equation or finding the solution to the quadratic equation. Here I am going to list out 4 methods of solving the quadratic equation, and the last one I will ignore that one, which is not for our syllabi for the 10th standard. Only I am considering 3 methods here. Now, solving the quadratic equation or solution of the quadratic equation. There are 4 methods of solving quadratic equation, namely a method of factorization by completing the square, and a solution by the formula, and also the fourth one, graphical method. This graphical method I am not going to discuss it because it is not for our syllabi. And furthermore, note that graphical method of finding the zeros of the polynomial, which we have discussed in the earlier video, the same thing can be also be adopted in finding the roots of or solution of quadratic equation, because the one and they are the roots and zeros are the one and the same, which I am going to discuss later. Now, roots of the quadratic equation. What do we mean by root of the quadratic equation? Consider 3 example following equation: 3x plus 5 equal to 0. Second one, x square minus 5x plus 6 equal to 0. Third one, x cube plus 2x square minus x minus 2 is equal to 0. Here, in one, we replace by replace x by minus 5 by 2, so that we will get what you can see here. 3 into minus 5 by 3, that is LHS I am going to consider, plus 5 equal to 3 are getting cancelled, that is a minus 5, plus 5 is equal to 0, that is RHS. And therefore minus 5 by 3 satisfy the equation given in 1. And if you're in 2, if you are going to replace x by 2 or minus 2, we get that is what is that? X square, 2 square minus 5 into 2, that is LHS, minus 5 into 2 plus 6 is equal to 4 minus 10 plus 4, that is 6, 10 minus 10, that is equal to RHS. And therefore this 2 satisfy the equation. And now you can see now, and also replace x by 3, we get what you can get, 3 square minus 5 into 3 plus 6, that is 9 minus 15 plus 6 is equal to 15 minus 15 equal to 0, that is therefore LHS equal to RHS, left hand side equal to right hand side. Therefore both 2 and 3 satisfy the equation. the equation x square minus 5x plus 6 is equal to 0. And now in 3, if you replace x by minus 1 or minus 2, we get that is minus 1 raised to 3 plus 2 into minus 1 minus of minus 1 minus 2 is equal to minus 1 raised to 3 is equal to minus 1. 2 into minus 1 is equal to minus 2 minus of minus 1 plus 1 minus 2. We can see here minus 2. Sorry, this is 2 and this is minus 1 raised to 2 means 2 into 1, that is going to be plus 2, and this is getting cancelled and this is getting cancelled, that is going to be 0, and therefore LHS equal to RHS in this case. And also replacing x by 1, we get LHS equal to 1 plus 2 minus of 1 minus 2, that is again going to get cancelled, 1 1 and 2 and minus 2 are going to get cancelled, that is equal to RHS here. And also lastly replacing x by minus 2, we get LHS equal to minus 2 raised to 3 minus 2 raised to 3 plus 2 into minus 2 raised to 2 minus of minus 2 and minus 2 only, and that equal to, you can see here, that equal to minus 8, and this is 8 plus 8 and plus 2 minus 2, and these terms are getting cancelled, that is going to be 0, and hence it is RHS. And therefore in the third case, minus 1, 1 and minus 2 are satisfying the equation x cube plus 2x square minus x minus 2 is equal to 0. And thus in each of the above equation, we see that minus 2 is called a root of the equation 3x plus 5, and 2 and 3 are called roots of the equation x square minus 5x plus 6 is equal to 0, and minus 1, 1 and minus 3, minus 2 are roots of the equation x cube plus 2x square minus x minus 2 equal to 0. And thus in general a real number alpha is called a root of the polynomial equation px equal to an x raised to an plus an minus 1 x raised to n minus 1 plus etc plus a1x plus a naught equal to 0 if p of alpha, that is the value of the polynomial at alpha, it must be 0, then we call that real number alpha as a root of the polynomial equation. And therefore minus 3 by 5 by 3 is a root of linear equation. 2 and 3 are called roots of the quadratic equation. Minus 1 and 1 and minus 2 are the roots of the cubic equation x cube plus 2x square minus x minus 2 is equal to 0. In few of the examples which I have discussed, I am going to define what is a root of a quadratic equation. In particular, a real number alpha is called a root of the quadratic equation ax square plus bx plus c is equal to 0, a not equal to 0, if a alpha square plus b alpha plus c is equal to 0. I mean, the alpha satisfy the quadratic equation ax square plus bx plus c is equal to 0. And we also say that x is equal to alpha is a solution of quadratic equation, or alpha satisfy the quadratic equation ax square plus bx plus c is equal to 0. And note here, recall the definition of 0 of a polynomial px is equal to an x raised to n plus an minus 1 x raised to n minus 1 plus etc plus a1x plus a naught. What is the definition of 0 of the polynomial? Now that is, alpha is said to be 0 of px if p of alpha, that is value of the polynomial at x equal to alpha, must be 0. And hence 0 of the polynomial is same as the root of the polynomial equation. And therefore, alpha is 0 of a quadratic polynomial is same as alpha is a root of the polynomial. Zeros of the polynomial and roots of the polynomial equation, they are one and the same. And note another note here, any polynomial equation with the px is equal to 0 of degree n has at most n roots. This is by fundamental theorem of algebra, and therefore the quadratic equation ax square plus bx plus c equal to 0, a not equal to 0, has at most 2 roots. This is the thing which we have considered here.